This is your recap for the final section in the cardiovascular system, which is blood vessels and circulation, chapter 21. So, with blood vessels, we talked about the five classes of blood vessels, which are arteries. Arteries are the vessels that carry blood away from the heart. They're going to carry oxygenated blood, and we refer to them as efferent vessels. We have arterioles, which are the smallest branches off of our arteries. We have capillaries. Capillaries is where gas exchange is going to happen, where we're going to drop off oxygen at our cells and tissues and pick up carbon dioxide. And then we have venules, which are the smallest branches that are going to come together to form our veins. And we have veins, which return our deoxygenated blood to the heart, and we refer to them as afferent vessels. Something I would definitely know is the order in which blood travels leaving our heart back to our heart through the vessels. So, leaving the heart, we have our elastic arteries going into our muscular arteries, arterioles, capillaries, venules, medium sized veins, large veins, which is going to bring that blood back into the heart. And then you had a couple different slides that showed you that in different ways. You have this slide that's showing you the path of oxygenated blood, where gas exchange is taking place, and deoxygenated blood. And then on your PowerPoint, you should have the filled out version of this heart, which is just showing the pathway from the heart through our arteries to our capillaries to veins back to the heart. So we took a look at the structure of our vessel walls. Both of your vessels, arteries and veins, are going to have three layers, starting from the inside, the tunica intima, media, and externa. But there is a slight difference. In arteries, the tunica media is a lot thicker than in veins. Then we looked at the differences between arteries and veins. Our arteries are going to be thicker. Like I said, the tunica media is thicker, so it's containing more smooth muscle. They retain their shape better and they're a little more resilient, where our veins are smaller and they contain valves. So, with those valves, I think I missed them on this page. Those valves are called venous valves, and these are valves found within your veins. And what they do is they help blood overcome the force of gravity, especially in our lower body. These are found in like our femoral veins and our thighs. And what these valves do is once blood goes past them, they close so the blood can't flow back down into your legs. So those venous valves are helping us return blood into our heart. Now we took a look at important blood vessels with arteries. The largest group of arteries are called elastic arteries, and their function is to get large quantities of blood from the heart. And some examples are aorta, our pulmonary trunk, and the common carotid, which is going up to your brain. From elastic arteries are going to branch muscular arteries, which we refer to as our pressure points, and they're the ones that are going to bring blood to our muscles and organs. And some examples are your external carotid, your brachial in your arm, and your femoral in your leg. And then arterioles are our resistance vessels, or what is going to meet up with capillaries, and they're able to dilate with lower oxygen levels. Then we do the same with veins. The largest veins we have, all tunica layers are present. Some examples are our superior and inferior vena cava and your jugular, which is coming down from your brain to your vena cava. We have medium-sized veins, which the tunica media is much thinner. Your external jugular, your brachial, and your femoral. And then your venules are what's going to collect blood from our capillary beds. And we discussed the different types of capillaries. Remember, capillaries are exchange vessels. And so capillaries can be continuous, which supply most of the regions of the body with blood. They're continuous because they have a complete endothelial lining, which allows water and solutes to diffuse. Capillaries can also be fenestrated. We find these capillaries in our brain, our endocrine organs, our intestines, and our kidneys. What fenestrated means is they have holes in that endothelial lining, so it allows for a faster exchange of water and solutes. And the third type are called sinusoids, which are found in your liver, bone marrow, spleen, and endocrine organs. They're a little more flat and have an irregular shape. They also have discontinuous epithelium, but they're going to have larger gaps between those epithelial cells, so it allows for a free exchange of water and solutes, but blood moves very slow through these capillaries. We then talked about how our blood vessels are grouped together. We have areas called capillary beds, and that's where one arteriole, our small branches off our arteries, is going to meet into several capillaries, which will join with venules. So this is like where the exchange is happening, where our arteries are meeting our capillary beds and then meeting our veins. A term to know is what a precapillary sphincter is. A precapillary sphincter is a muscle made of smooth cells that helps control the blood flow into the capillary bed. So that sphincter can open or close to allow more or less blood through. So this slide is showing you what a capillary bed looks like. You can see over here where our arteries and our arterioles, the small branches, are going to meet up with our veins, which are over here. And this in-between section is going to be our capillaries. We talked about vasoconstriction and vasodilation. Remember, vasoconstriction occurs when your diameter becomes smaller and it increases the blood pressure. Vasodilation is when our blood vessel's diameter becomes larger, and this is going to decrease our blood pressure. We then talked about the physics of blood flow and how that works. But the last thing you need to know for your test is blood pressure and your pulse. Your blood pressure is a measure of the pressure in your arteries. We measure it as the systole over the diastole, and what that's measuring is the pressure in your arteries when your heart's contracting and relaxing. So blood pressure is always going to be higher in your arteries than in your veins. And then your pulse is the difference between systolic and diastolic pressures. And if you have hypertension, you have high blood pressure, and if you have hypotension, you have low blood pressure. And then we took a look at different pathologies. The pathology that you need to be familiar with is an edema. And what an edema is it's an abnormal retention of body fluid, which gives you a lot of swelling, like in your legs. All right, and that's it for your cardiovascular system. Happy studying!